I'm curious if it's the same topic. And oh, it's a little bit messy, okay? Okay. Number 28, we have Arturo with a savings account. Boop, boop. I apologize for the whole YouTube live thing not happening, but hey, let's be honest, it was one less thing for us to worry about, right? Okay. Boop, boop. So, total investment, $2,700. Savings account pays 9% interest. Compounded quarterly. Interesting. If it was compounded continuously, do you guys remember the really nice equation that goes with continuously compounded interest? PERT. Principal times e to the RT. That one's super nice. Why was this one harder? It wasn't that one. It was the other one. And the other one says A equals, did you guys find that formula? Without it, you would have been lost. P times to the NT? This is the compounded n times per year formula. So without that one, that's why I'm like, I probably should have taken it off. But it is a valid formula. It's just not as nice as the exponential growth one as far as the easy p times e to the RT. So without that formula, nasty. With that formula, easy. Because then you just plug and chug what you got as long as it all fits in nicely. Like the rate is 0.09%. The rate is over the number of times per year. Quarterly means 4 quarters in a year, 4 quarters in a dollar. Think of it that way. What were you supposed to find? Ah, good. When will the amount in his account reach 4,550? Oh, thank you. I was like, why is his savings account going down? That's awkward. Okay. I was just demonstrating it's okay to be rusty after summer break. Okay, so now we do. What was this problem meant to make you review? I don't know. Maybe there's weird formulas out there that you wouldn't necessarily remember from what you've done so far. You are big stuff, doesn't mean you know everything. Sometimes you have to look things up still. But then also, what we need to solve for. Okay. So I'm going to basically just go real fast in the sense of, you guys know division, that's not a big deal. But the problem that most of you would have come up against that you might have not remembered how to do is, how do I get to an exponent? Yeah, you could try like a log-based something, but don't do that. It's nasty anyway. So why not just throw in the nicest logarithm that we know? What's the point of that? What's the property tell me with logarithms raised to a power? Comes in front. So then at that point, the nice thing is if you think about it, there's going to be a 4 and a t. I want to solve for t. There's going to be a 4 times an ln of blah, so I could take the ln of, that I already have, divide it by the 4, and divide it by the ln of blah. Throw that whole thing in my calculator, and what have I just solved for? Got him. Probably just round them to the nearest year, right? Okay. We can peek at the answer key, but that's number 28. But there was that nasty formula that I, was really mean and didn't write down, so it seemed like I was doing magic. Lo siento, it's not magic, it's math. Okay, number 29. Can anybody tell? Like, it's an inverse, no big deal, right? What makes this harder? Yeah, 17 pi over 5 is not on the unit circle. So number 1, the whole over 5 thing, you're like, gross. It's not a 30, 60, 45, right? That part's rough. But the other part, the other part is that it's beyond one rotation of the unit circle, right? How would you guys visualize this, dude? As a mixed number. So where would that approximately be? Oh, it's less than, oh no, it's not, right? Isn't one rotation 2 pi? 3 pi, so I have to go, okay, right? And then 2/5. I don't know, something a little bit less than a half, right? So I can tell you about where 17 pi over 5 is, but the problem is, well, how on earth did a cosine inverse of cosine? Does anybody remember where cosine of inverse is restricted between? Every inverse trig only pops out certain answers. Sine inverse and tangent inverse go between the first and fourth quadrants, negative 90 to 90. Cosine inverse goes in between 0 and 180, or 0 and pi. That's just because there's infinitely many answers because of coterminal angles, and so we have to restrict it so your calculator only gives you one answer every single time. So this is the one, what we call principal value. So I can't just say, yay, they're undone, 17 pi over 5, because it doesn't work, because it's not within the legal range. So what angle in between 0 and pi? What angle up here would have the exact same cosine value as down here? So we have this 2/5 guy here, right? We could have a 2/5 guy here. We could have a 2/5 guy here. Trig is all about symmetry. Which one would have the exact same, whatever it is, the exact same cosine? Second quadrant, because only in the second quadrant will the x be negative. First quadrant, it would be positive, so that one doesn't work. So it must be in the second quadrant. And how did I just say a second ago that the answer would be, wait a minute, not 2 pi over 5, that's less than a half, but this has a measure of 2 pi over 5. How can I answer, goodness gracious, how can I answer 3 pi over 5 as my final answer? What did I do? Yeah, I figured out second quadrant. I figured out this is 5 pi over 5. And what was the symmetry? What did I have to not go past, not go up, but go back? 5 pi over 5 minus 2 pi over 5 is 3 pi over 5. Is this a huge calculus BC topic? But do you guys kind of see the things that went into finding the answer? We had to think about what's the legal quadrant from my restrictions, and then we had to just play with symmetry. I was just seeing if you could play with symmetry. But not a huge topic, and to be honest, probably not on the quiz on Wednesday. Okay, what else do we got? 51? 51. What do we got? Ooh, we're finding everything. Go team. Doesn't this sound kind of like the pre-cal for 15 identifies? Okay. So domain, the x values, range, the y values. Vertical asymptotes come from where again? Good, the denominator. Oops, undo. That wasn't helpful. Horizontal asymptotes, where did they come from again? Otherwise known as degree tests, otherwise known as limits to infinity. But yeah, talking about the coefficients and the degree tests. Points of discontinuity. Oh, holes. Aren't those on the bottom too? How do we know which one's which? Okay. Did anybody factor the bottom to start? What'd you guys get? That's a minus, right? Is that good? Okay. What do you notice right away? The x plus 3, right? So technically we could say this is the exact same thing as 1 over 2x minus 1 such that x cannot equal negative 3 because any shared factor is really just a whole. It's saying, hey, at that 0, he can't exist. Maybe something useful to think about. Let's start identifying things. So domain, what x's are not allowed? Negative 3 and 1/2. Range. How low, how high? Maybe it's easier if we think about some other stuff and come back to range, right? Why am I going to say my only vertical asymptote is 1/2? Good. Negative 3 is removable. That's going to be my other discontinuities. Why am I making it an ordered pair? And answering negative 1/7. I thought it wasn't able to exist. If I plug in negative 3, that's negative 6 minus 1 is negative 7. Can't I actually find the place by plugging it into my function when I remove the whole? What am I missing, guys? Domain, range, discontinuities. Oh, horizontal asymptotes. Yeah. Who wins, top or bottom? Bottom wins. And if bottom wins, horizontal asymptote is out. Y equals 0. So theoretically, if it's like, oh, isn't this kind of like one of these dudes? Basic graphs. So theoretically, my range is probably y cannot be who? Yeah, unless something weird happens and it crosses and then it levels out, I don't think y can be 0. And if you guys want to check and see, you could always set this equal to 0 and see if it's actually positive or possible. So if I solve, that whole thing would come up. I would end up with x plus 3 is equal to 0, which is at x equals negative 3. Oh, and that's not allowed. So are there any zeros? Nope, not for y. Okay, so how do I graph it? Piece by piece. There's my 1, there's my 1/2. I have a vertical asymptote, horizontal asymptote. Whole is going to be at negative 1 and 2 and 3 and like some sort of awkward negative 1/7. Who knows? Not me. What's the sad part? Unless you were thinking of him, you probably wouldn't have a great picture as to what's going on, but then we could always do. Remember? There's no shame. Couldn't we do a couple of these dudes? Right? We could plug in and we could end up with, oh, I can't even read the function, 4 over 2 minus 1 is 1. Oh, hey, 1, 1. Sweet. But if we kind of know what's going on, maybe we can make our function without getting too crazy. Maybe I can do the same thing over here with like a negative 1. So that would be 2 over negative 3 times negative 2, 6. How does that make sense? Negative 1 is 2. Negative 3. Oh, that's a negative. There we go. So negative 1/3 would be here-ish. Go to the hole. Swoop, there he is. Anyway, is that pretty close, David? Something like that. Just reviewing all that pre-cal stuff. And if worst comes to worst, you can throw a table in. Oh yeah, that looks super close to what I had. Okay, what else do we got? 99. Go big or go home. Let's go to the end. Ish. Okay. I'm guessing that time is running short, just thinking about chapel day and how we usually get out for lunch around now. There were a few things that were behind the scenes, like gravity is always at work, and gravity in terms of meters would be negative 9.8 meters per second squared. That's a constant. That's our initial acceleration. It's dropping, which is, well, I should say gravity is pulling it down. That's why I made that a negative. I went ahead and used some equations like last year that you guys would have used in the motion section of your AB notes, where I was plugging in things like the velocity equation for rectilinear motion, just straight up and down. We're not doing parametric equations yet. It's just initial acceleration times t plus initial velocity. And if it's being dropped, initial velocity is 0. Oh, sorry, that looks like division. I was just trying to squish it in, so I just did v of 5, plugging in 5 to get my velocity after 5 seconds, and then I used my position equation with the 1/2 acceleration plus the initial velocity times time, which is 0, plus the initial position. So if I were you guys, I would just peek at the beginnings of motion back first semester right around derivatives. Does that make sense? And then there were just some formulas I plugged into. Guys, tomorrow, tonight, what's your job? Start thinking through the summer packet as far as topics and problems that you would like to see or type